Assalamu alaikum wa rahmatullahi wa barakatuh. How are you guys doing? Welcome to another lecture for Computer Science 9618A2 Paper 3 Advanced Theory. And today we'll be starting chapter number 16, System Software, specifically 16.1, Purpose of an Operating System. Now I'll try my best to complete this entire 16.1 in one video, but if it is consuming a lot of time, then I might have to break it in two videos. Well, let's just find out, as it will be something like maybe 45 slides, and that would mean something like maybe a 50-minute or an hour long lecture, which I'm pretty sure you guys will not be too much interested in, so I might just break it into two parts. Anyways, the purpose of an operating system, you can define it from two viewpoints. One viewpoint is the internal viewpoint, that what is going on inside the computer, and one is an external viewpoint or the user's viewpoint. Internally, the purpose of an operating system consists of activities that are organized in order to use the resources available in the most efficient way. Externally, we have all the facilities, all the tasks that are done by operating system, they are considered as the purpose of an operating system. Like you have studied in your AS as well as O levels, that purpose of operating system includes something like task management, user management, file management, etc. All of these are the facilities provided by the operating system to the user. However, about that you have discussed in detail in your AS. So over here in A2, in chapter number 16, we will be discussing about purpose of an operating system from an internal point of view, like what goes on inside the computer. And internally, the purpose of an operating system is to reduce the usage of resources as much as it can, so that more jobs, more tasks can be done. The major resources associated with the internal viewpoint are the CPU itself, like the CPU's processing power, basically, the memory or your RAM, and the input-output systems. Resource optimization. Resource optimization is very important in maximizing the performance and efficiency of an operating system. If you carelessly utilize the resources, your computer will not be able to perform half the task it is doing for you currently. It aims to utilize hardware resources to their fullest potential, along with maintaining or ensuring fair distribution and conflict-free operation. Maximum productivity can only be gained from your computer if resource optimization is used. Equitable resource allocation is done to processes and users, otherwise it can cause chaos. Maintaining a balanced load to avoid system crash or slowdown is also considered an important part of resource optimization. Now, in order to optimize things perfectly, the CPU uses something that is known as scheduling algorithms, or simply scheduling. It is a fundamental aspect of resource optimization. It focuses on the allocation of CPU's time basically to various processes. Operating system structure. An operating system, as you know very well, in general provides a platform for resource management and user facilities. Logically, an operating system has two modes, user mode and an expert mode or kernel mode. User mode is available for the user or an application, the basic GUI interface that you deal with every day. Kernel mode or expert mode or programmer's console or developer's mode, there can be many names for that. It has the sole access to part of the memory and to certain system functions which are usually hidden in user mode. The kernel runs in the background. Kernel is, how should I define it? A kernel is basically a software program that always runs at the core of a computer system, and it is the job of a kernel to manage everything else. Rest of operating system runs in user mode, so individual parts are only accessed when needed. Basically, all of these services, this is kernel having the actual control of your computer, your hardware, but as different applications when needed interact with the kernel to run things smoothly. A structure of operating system works by the kernel calling on the individual services when required. If you have ever pressed Control, Alternate and Delete, I'll do that for you. Then you can open the task manager, and over there you can see there are hundreds of services running. I'm talking about these services. These are all controlled by your kernel, or these are all called by your kernel. The direct memory access or DMA controller is needed to allow hardware to access the main memory independently of the CPU. When CPU is carrying out a programmed input or output operation, it is fully utilized during the entire read-write operation. Hence, the DMA frees up the CPU to allow it to carry out other tasks while the slower I/O operations are taking place. Now, if you recall, the speed of a hard drive is several times lesser than the speed of RAM, and the speed of RAM is at least 10 times slower than the speed of registers, the speed of CPU, or your system clock in general terms. So that's why if the CPU is performing a read-write operation for the CPU, it takes a lot of time from CPU's point of view, because during that time the CPU cannot do anything else. Hence we have the DMA, the direct memory access, so that CPU can shift the job to DMA. So while DMA is reading or writing data from the memory or from the hard drive, the CPU can do something else. As you can see, this is a rough estimate. Just for your information, you don't have to learn this table, and or you'll not be asked about it in the exam. Like I've told you before as well, sometimes I add a little bit of extra seasoning in order to give you a much clearer and much brighter picture. But that does not mean that everything I discuss with you will be asked in the paper. Anyways, so hard disk has up to a data transfer rate of up to 100 megabits per second. A mouse has a rate of about 120 bits per second. A laser printer has about 1 megabits per second. Keyboard has about 50 bits per second, compared to a CPU which has a speed in GHz 30 gigabits per second to over 500 gigabits per second. It is essential that management of CPU usage is vital to ensure the CPU does not remain idle. Otherwise, if you're sending some data to hard drive's speed is 100 megabits per second, whereas CPU, the minimum speed of a CPU nowadays is 30 gigabits per second. So you can imagine how much time, for how long the CPU will have to stay idle. For hundreds of clock cycles, for hundreds of seconds, CPU will be sitting idle in order waiting for the data to be completely written to a hard drive. That's why we have the DMA. So DMA, basically whenever CPU has to perform a read-write operation, it gives the data to DMA so it can deal with the slower devices, whereas CPU along with the main memory can perform more tasks instead of waiting. User interface, abstracting hardware complexities. Now what exactly is the user interface? Everything you see on your screen is a part of your user interface, because every operating system nowadays uses GUI, graphical user interface. The OS acts as a mediator between the user and the hardware, or a bridge between the user and the hardware, and it hides the complexities of hardware operations from the user. You can just click on something and the task will be done, and the complex operations, the long codes running behind that, will be completely hidden from your sight. This abstraction allows the user to perform tasks without needing any in-depth knowledge of hardware mechanics. For instance, when you save a file, they interact with a user-friendly interface. You just use your mouse to right click on a menu, create a new file, or you just use Control S on your keyboard in order to save a file. There's a whole long process of how that file is actually saved on your hard drive in a particular way, and that complex, you don't need to know that in-depth knowledge of it. The OS handles all those complexities for you, making your life, your work easier by allocating. Now what the OS does, it looks for free space on the hard drive or your SSD. It would then save the file over there. It would enter that as a new file in a file system, or file allocation table. It would make entries that, okay, this is a new file at so and so hardware location, it is saved, it is taking this many bytes, and so on. All of that is hidden from you. You just see a green bar moving on screen and your data is saved. Types of user interfaces, as you know very well, we have two types of user interface: command line interface, CLI, and GUI. In command line, OS relies on text-based input. These were the conditions in initial operating systems. However, you can still access command prompt in any version of the Windows. This requires users to learn specific commands and have a better in-depth knowledge about how computer works. It is very powerful. It takes less space in a computer memory. It runs very fast, but it demands a steep learning curve and a good understanding of commanding knowledge or syntax. However, most of the computers, or devices I should say, nowadays uses GUI, graphical user interface. It presents users with visual elements, icons, buttons, windows, so interaction is much easier. Hence, by applying GUI, basically the computer became easier to be used by almost everyone around the world. Streamlining input and output processes. Now these are all the things that are being handled by your operating system in the background. Okay. Input mechanism. The OS translates action performed on input devices, like whenever you press a key, the OS determines which key was pressed. Or whenever you click a button on mouse, it is the OS who translates and figures out what you're trying to do. This translation is seamless, allowing user to interact in a way that looks like real time. Output management. In a similar way, the OS converts signals into human readable format, into text, into images that can be seen and understood by the user, and displays them on screen or in form of a printed document without any delay, in kind of like real-time environment. Then the OS also manages drivers and device integration. Drivers are those programs that control a specific hardware, and with the help of drivers, the OS is able to interact with the many devices that are connected with your laptop, with your computer, such as your mouse, scanner, printer, headphones, speakers, and there can be many other things, even your graphics card. And then by the help of drivers, OS is able to control and translate between the data being passed from one device to another. Modern OS have a feature, or rather we should say modern devices comes with a plug and play feature, where new hardware is automatically recognized and configured, and you basically don't need to do anything, which simplifies user experience. Nowadays, operating systems have a range of features which are designed to make computer accessible to just about anyone who can read English. Even those people who have disabilities, computers nowadays are adequate enough to be used by such person. These include screen readers for the visually impaired, voice recognition for those who are unable to use a keyboard, and various other assistive technologies. Users are able to alter settings to their preferences. You can change desktop themes, you can change wallpapers, you can change icon styles, cursor speed, and so many other things. OS offers an array of shortcuts and automation tools as well, such as keyboard shortcuts to even sticky keys and so many other performance related shortcuts. The operating system provides easy to use interfaces for security functions as well. You can easily put a password on your computer, or you can easily put a biometric lock on your laptop if it has a biometric scanner, or your cell phone. It also provides basically, this simplicity ensures that security measures do not become a barrier to user experience. Everybody is able to deploy the security measures safely and easily on their computer systems. You can set permissions, you can manage user accounts, hence striking a balance between security and usability. To assist users, whether they are experienced or newbies or novice, in navigating and resolution issues, operating system also includes help systems to provide information, troubleshooting guide and tips. Next we have process management. Multitasking is kind of a very commonly found ability in today's devices, where operating system is able to execute several processes concurrently. We kind of had a look at it in our previous chapter as well. A process is a program in execution characterized by its code, data and activity state. These are the three basic characteristics of any processor that is being performed in a microprocessor. Every process requires some resources such as processing power, some RAM or memory registers and I/O devices for execution. A process control block is a data structure that contains all of the data needed for a process. It can be created in memory when data needs to be received during execution time, and it usually has the following structure. This is a diagram for you as well. It has process privileges, like what resources is the process allowed to access. It has register values, like what the value of PC, MAR, MDR and ACC for that particular process. It contains process priority, like whether processor has the highest priority, medium or low priority, and any scheduling information. Amount of time needed in terms of clock cycle for the execution of the complete process. This is an estimated time only. It may be finished in less or more time. Process ID as well, which allows to be uniquely identified, as well as process state. That basically means whether the process is running, whether it is ready, or whether it is blocked. A blocked process is basically a process which cannot run due to some lack of some resources. Like for example, a process that needs to access a specific memory location, but that location is somehow not readable at the moment. Hence that process will become blocked. A process can exist in one of the several states. Running state, when the process actively executes instructions on the CPU. It can then go to either the ready state or the blocked state based on the operation requirements. Ready state is when the processor is ready for execution, but it is awaiting CPU allocation. Like the CPU is not currently free and it is waiting for its turn to be run. A queue system often manages the order of these processes. And then we have the blocked state, also referred to as waiting state, when a processor awaits external events like input or output completion, like the process is waiting for some input from the user or is waiting because an output operation is happening. As we have discussed, input output takes very much time as compared to the processor's internal time, or the time for processing instructions. Okay, so next we have process scheduling calculations. These are a few important things that you should know before we start our discussion on process scheduling. We have something known as turnaround time. Turnaround time means that completion time, what is your actual completion time minus arrival time, that gives you the turnaround time. This is the duration between a process arriving and its terminating, like how much time did it take to completely execute a process. Then we have waiting time is equals to turnaround time, or the time it took to be completed, minus burst time. This is how long a processor waits idle before it is fully executed. Burst time is the actual time for which a process utilizes the processor, whereas turnaround time is the total time a process stays in a processor. So if you minus total time minus actual time the process was being executed, you'll get the waiting time. This would show you how long a processor waits idly. Average waiting time is equal to waiting time for all processes divided by number of processes. Now these are some calculations that would come in handy in the paper. Most of them are kind of like a precaution, but it's better. I have a feeling that they would be coming in handy in some of the questions. So average waiting time is how long a process has to wait on average before it is fully processed. Now we use something known as scheduling algorithms inside a microprocessor. Every microprocessor uses scheduling algorithms, or every operating system uses scheduling algorithms in order to make sure multitasking can handle efficiently, smoothly, and effectively. Every process would get optimal resources, and every process would run for an optimal number of clock cycle, and it would be dealt with very quickly. So since the lecture is getting long, I don't want to bore you guys, so I'll be ending it over here. This is first half of 16.1, purpose of an operating system. Inshallah, in the next video we'll take care of the other half, the scheduling algorithms. Till then, take care. Allah Hafiz. Do tell me in the comments whether you find this video useful or not. Give me a thumbs up and share it with your friends. Take care. Allah Hafiz.